No, you're not. I can hear you.
Oh, okay. Sorry, that's changed. I saw the little red mute icon. Okay.
Yeah, you may have been on mute, but you're allowed to unmute yourself. So
right, yeah, I didn't have the button there. Right, thanks everyone for coming and deciding to be inside. My office is absolutely sweltering, so I've got a fan on, and rather than being in your garden drinking some beer or whatever. And well done to all those who were brave enough to put their video on and show their COVID haircuts. It's always interesting to see how people are coping with that. So today we talk about automating security in Azure and application security. I'm John Staveley. I'm a contract by trade. I do a lot of MVC, SQL Server, Angular type work. So today we're going to talk about DevSecops because it's quite a sexy term, and Paul left security and what all that's about. In DevOps, you're amplifying all of the feedback back into dev, so they're doing the processes better and better. But this is about amplifying the security feedback you get from downstream systems. One of the things. We're going to talk about how to enhance the overall security baseline by using standard templates that have been pen tested and security tested. And how we're going to do this, we're going to automate the deployments in Azure DevOps using Azure Pipelines and ARM templates. So ARM templates are a method of setting up your infrastructure in Azure, just using a document. So some of the mechanisms we can use to try and understand more about security. So pulling the security left, that means doing as much security whilst you're coding, designing, developing, deploying, building, rather than leaving it all to the 13th sprint and you do a pen test and then do another 2 sprints to try and fix all the problems. You pull that security left. So there's a number of techniques we're going to cover today to try and understand better security. So we can do a bit of lightweight threat modeling, so not a bureaucratic process where we convene a team. Static analysis, so that's understanding code, platform setup, because the platform's all automated through an ARM template. What components you're using, that's NuGet packages, NPM, that kind of thing. How I can improve and guarantee security using unit tests, and then do what's called dynamic analysis. So OWASP I've heard described as sort of a mini pen test. It's more of a toy, but it does provide some useful security feedback. And then briefly talk about security acceptance tests and what you can do there using SpecFlow and Selenium to test your security and look for security regressions. So all of the code for this is on GitHub. I'll provide that at the end. Feel free to nick all the code, and I'm going to put all the slides on SlideShare. This was originally a 2-hour talk, so I'm going to stick to an hour. I overran when I did the demo with Pete, so you may see me speed up as we go along. So why should we care about security? Well, Azure hacked, I think, on Wednesday, and they admitted that they lost 9 million records. The fine for that is yet to be assigned, but it's going to be in the millions. British Airways were fined last year, and Marriott, again, it's in the millions. And then really like the list goes on and on and on and on. And with GDPR coming in, it all means lots of money going out the door in terms of fines as opposed to paying for your pension scheme. So security is worth caring about. So DevOps is a very cool term at the moment. It's basically a fast flow of work from dev to operations, and then also amplifying those feedback loops. So find out what works and how ops can better support and maintain the system. But with DevSecops, we're pushing secure code through to ops as much as possible and understanding the security issues as it's going through our build pipeline, and then amplifying any security feedback back into the requirements and dev process. Trying to understand what we can do in terms of improving our daily security work and giving our developers a secure by default code and platform rather than having to start from the ground up. So the Security Essentials project I'll be talking a lot about is one of those. So it's been pen tested. It's got OWASP top 10 protections in it. And it's also got an ARM template that's deployed into Azure that has been very well security tested. So all my subsequent diagrams are top down, but this one is left to right. So when we mean pull left security, we're understanding our security earlier in the pipeline. That's at the requirement stage, the design stage, the coding stage, the testing stage, rather than doing a hardening sprint at the end where we find all the security bugs. We're pushing code through that's as secure as it can be, so it never gets to the point where it needs to be pen tested. You still do a pen test, but I'll come to that later. So the benefits of taking this approach, the secure means fewer security defects. So you're finding all of the security bugs up front as opposed to having to wait for that pen test, reducing the average time to detect a security issue, again, because all of these checks and controls you're going to, and a lot of this is automated. So this isn't a massive overhead on the developer. I'll go through that as we go through. And because we're doing DevOps, everything's automated. You can push code to production very easily. And it means if you do find a security flaw, it's very easy to put to production much quicker. And studies have found that having fast moving code that you're pushing all the time, it provides a moving target to developers, which is harder to hack. So what we're going to go to secure. So about 4 years ago, I took a roadshow of security talks around the country. It had as its base this Security Essentials project. This is full-fat.net. We don't really, I know, I appreciate that a lot of people are on core right now, but if you're retrofitting security onto a full-fat.net project, it's quite a good template to use. It's equivalent of doing file new MVC project, but with all of these security features in it. So checks for pwned passwords, enforces SSL, checks for cross-site scripting, vulnerabilities, cross-site request forgeries, checks the HTTP headers. It's not really relevant to the talk, but I had to deploy something, so it formed a good base. So what I'm going to deploy into Azure is, so here we've got the World Wide Web with our keen customer and the nefarious attacker sending applications requests through into a firewall. I use Cloudflare because it's the best of class. And then I've got Azure App Service sitting behind that, talking to a Key Vault, which holds our secrets, a SQL Azure instance, which holds all the data, and some blob storage. So we're going to set up all of those resources using a combination of PowerShell and an ARM template. So all the demo code is there. Please go and steal it if you find it of use. We're going to be talking about infrastructure as code. So this leads to repeatable automated deployments using an ARM template. You can set up Cloudflare. If you've not heard of that, that's a web application firewall. So we're going to set up some settings that force TLS, HTTP2, enable the WAF. Cloudflare is really useful and protects against denial of service, which you can't really do if you're just doing application code. Protects against SQL injection and many, many other features. We lock down the access of the app service just to Cloudflare. So the app service can't talk to anything else other than Cloudflare. All our requests come through there. So we guarantee that we get all of these protections. We set up an Azure Key Vault to protect our secrets. So it's all the passwords, usernames, and then use a virtual network to secure access to assets like blob storage and SQL Azure. For blob storage, obviously, we're setting encryption at rest and at transit, and all of the requests are firewalled to the virtual network. So a lot of this stuff, if you read the guidebook on how to set up Azure securely, you will come out of that. But we set up a template that's got this already. So you've got something that's best of class that you can just steal and reuse and get a better baseline of security. With SQL Azure, you got transparent data encryption, automated vulnerability scans once a week, automated backups for that availability component. Okay. So what it looks like in the cloud is that. So you've got App Insights for logging, the virtual network, and then SQL Server with the database. This storage account is for blob storage. Service plan, which says how many requests it can service per minute in effect. The app service where all the code sits. A security group which defines what can talk to what, and then an availability test, which basically pings the website to make sure it's on. I'll say ARM template, right? So an ARM template looks like this. It's JSON. I don't like JSON. It looks hideous. But basically, if you want to set up a SQL server, you give it a name. It's of this type. It's in this location. That's the data center type. And then you give it a number of properties like the admin username and password, and then set up some firewall settings for it. So all of the resources, app insights, the app service, auto scaling rules are part of this resource template. And you fire that Azure and it spins up all of these resources that we see here. So why automate it? I mean, yes, you could just create a Word document and ask someone to plug through each of those steps each time. But I find automating is good because then when you're testing changes to your resources or your application code, you're pushing it through to QA, to UAT, and then to live. It's been through multiple environments. So when it gets to live, it's really old news. You've already had those changes tested in multiple different environments. If you need a pat testing environment, a DR environment, anything like that, you just parameterize it slightly differently and you can spin up a new environment, deploy the code to it in a repeatable, reproducible way. So what this makes is that your continuous integration, continuous deployment pipeline is your heart of security. Anything that gets pushed through into that build process has the rules enforced on it. So you need to carefully control who has access to that, who can change the build pipeline. So that any changes that might, for instance, weaken security, if there's a nefarious actor in your organization, it gets logged and audited. So my Azure Pipelines looks something like this. I've got a NuGet restore. I'll show you what Azure Pipelines looks like in a minute. NPM, build and package all resources, then do the security unit tests, code analysis using fxcop, component analysis using various different applications, platform checking. So we've got an ARM template. There's a checker you can use to make sure those settings in the ARM template are the most secure possible. None of those will pick up whether there's any malware been checked in as part of your code. Also, we need a credential scanner to make sure a developer hasn't accidentally checked in some admin passwords. We'll then publish the artifacts so they can then be deployed to further environments. So that's your fast feedback for the developer. And then you've got your slow feedback. So it deploys to Azure, it sets up your platform as a service, as we've seen, sets up the firewall using a load of PowerShell scripts, deploy the code to integration server, run the security acceptance tests, do a mini pen test using OSAT, and then if you need to, then tears down all of that paths, you're no longer paying for it. So Azure DevOps secrets and marketplace. Right, so Azure DevOps looks like this. So when I check in my code, I will put a pointer to the Azure Pipelines. So Azure Pipelines is a YAML file. So here I've got my build and unit test step. It's on a hosted VS 2017 instance. So I've got the binaries I need. Here I'm doing a Sonar Cloud setup. NuGet install, NuGet commit, here's build. So it's all text, and it enforces that you set the unit tests and they run, and I'm doing all of this OWASP dependency checker and any other security checks I need. So here it's just a two-step build process. So I can edit in that. I find this is the best way of editing it, editing the Azure Pipelines. So I'm going to go edit here. Because unlike in Visual Studio, you don't get any kind of IntelliSense. So let's say I want to put in an OWASP dependency checker. Here it goes, these are all the parameters, whereas I get nothing in Visual Studio. It's just a text file. But when I save this, it then commits it back into GitHub, and then will trigger a build. So if I wanted to add in a new kind of security check, I'd just go to the marketplace. Let's say I want the Puma Scan static checker. Come on, wake up. All right, okay. Okay, right. So, and I just click on that and then click add into pipeline. And then as you saw before, I edit it. It has a template that I can fill out of information that will perform a scan for me. Okay, and it's not letting me back, is it? So the way I store secrets is I put them in Azure Devops. So there's this variable section here, and all of these can be inserted into Azure Pipelines. So here I've got my Cloudflare user service key, which basically allows the user to control everything that's in my Cloudflare account, and an encryption password and various other secrets. So they get injected into the code. They're not used in the code. I don't have to check that into the code. They just get stored once and then used afterwards. Okay, so how are we going to pull security left, i.e. earlier in the development cycle? So this picture is from a book I'm going to recommend at the end, and I refer to this constantly throughout the application. So a developer thinks about changing code. So they have some requirements. They're going to think about making some changes. This is the pre-commit stage. So at this stage, you can do something called lightweight threat modeling and IDE checks. So we're going to look at those. Then they commit the code to a source repo. Here, continuous integration kicks off, and it can perform software component analysis and security static code analysis, security unit tests. Then it gets some binaries, which are committed into the repo as well, so they can then be deployed. And here we then can do dynamic security tests and automated security attacks with OWASP SAP. And then in production, you've got monitoring, continuous vulnerability scans, and automated runtime defense, and that feeds back security information to the developer. So you're constantly improving the way you your security profile. So first up, we're going to look at the pre-commit stage. So when the code is the design, where and how do you catch security problems in the design? We're all agile now. We don't do big upfront design. So if you work with some of the big organizations like Facebook, they will do something called lightweight threat modeling. So the threats can be categorized in the following way, using this STRIDE acronym: spoofing, pretending to be something or something you're not; tampering, that's sniffing something or changing something at rest, in memory or in transit. So if you're not locking down your system correctly, people can get access to it. Abbreviation, pretending you didn't do something. Information disclosure, this could be as simple as showing your error message to a person or allowing them access to resources they shouldn't have. Degrading or preventing access to a service using denial of service, or elevation of privilege, something you're not authorized to do. So a really great tool that I've found using this is the Microsoft Threat Modeling tool. So you can get it from that URL. And it has a great Azure template. So a lot of security professionals have come up with this template, which show how all of these threats that you can have by linking resources together. Okay, so this is my setup in Azure. Here I've got a user talking to a browser. The browser is then talking to Cloudflare. And the Cloudflare is talking to an app service. And the app server is talking to blob storage, SQL, Azure, and Key Vault. So this took me about an hour to set up, and it shows the interactions between it. So Cloudflare sends HTTPS to the Azure App Service, and it sends HTTPS back again. And by modeling it in this way, you can understand some of the threats and some of the assumptions about the threats you're using better. So once you've done that, you can have a look at something called the analysis view. So this uses the stride categorization. So here you've got a denial of service, and when you click on it, so someone could perform a denial of service by threats, by putting lots of requests between the firewall and the app service. So then it breaks down here, and this is between the firewall and the app service. An adversary can fingerprint an Azure web application or API by leveraging server header information. So here's the possible mitigation that it suggests to you, and there's 2 links there. So I've put, this has been mitigated, and the justification for that is that all the server headers have been removed from HTTP headers. So if you know nothing about security, then it gives you some good ideas on how to mitigate those potential threats. So here we've got an information disclosure threat. An adversary can read confidential data due to weak connection string information between the Azure App Service and the SQL database. Possible mitigations. You should use these connection strings settings. So this I've put as mitigated, and I've mitigated by applying those connection string settings. Now here I've got potential elevation of privileges threat, again between the app service and the database. An adversary can gain unauthorized access to SQL database due to weak network security information. So I've said this needs investigation. So I can't say out of the box whether this is mitigated in some way by my setup. I just said someone needs to look at it. So that can feed back into your requirements. So let's say that a developer is engaged in CV-driven development. Okay, where is my? And they kind of like the look at the Azure Redis cache. So let's just quickly model that. So I've got a request coming in. I'm going to model some requests getting from the Azure Web Service. Let's just say, I know nothing about Redis cache, so this would be a good experiment. Okay, so I've modeled requests going from the app service to the Redis cache and back again. So if you go to the analysis view now, it showed up a whole load of requests that I haven't considered. So for instance, there could be a denial of service attack. An adversary may block access to the application API hosted through a denial of service attack. And here are a load of links that I can look at to see how I can mitigate that. So let's say I knew nothing about Redis cache, and I'd have to go to security team and say, could I use this application? I already have a head start on understanding what the security implications of using that tool would be and how to mitigate some of them. Okay, so next one, so in the pre-commit phase, we've got IDE checks. This is sort of the thin end of the wedge of security testing. It can spot some basic security errors like SQL injection and weak cryptography. They're as good as how much you pay for them, really. Some of them just use pattern matching, all have IDE integration. Most will also run in Azure Devops. So if a developer gets sloppy and forgets to look at the warnings, they'll get reminded in Azure Devops, and that will get audited. Some of the better ones allow building of their own rules. They should have a low false positive rate and give code examples and link to tutorials on how to solve security issues. And also define exclusions so you don't continuously get reminded about something that is not an issue. So one I'm using here, So let's say I've got a README and say, it's a good thing I didn't use MD5. Well, that's pattern matched on the fact that it's MD5 and it's classed as a critical security problem, which it's not because it's just in a text file and it's not actually been used. So that's one of the cheaper ones. The more you pay, the better job they do of testing. So in terms of IDE checks, you've got a number to go at. Each of these things teach you something new about your code. Devkim, which I've used, helps you find insecure hash and encryption algorithms, insecure URLs, not using HTTPS, storing secure credentials in code. It doesn't do all of them, like it won't find a service bus credential, for instance. Then you get into the paying ones. So you've got Scan, a free and a pro version. Checks for secrets, compiler, secure piler settings, auth settings, Veracode. You need an account to run it. Checks for SQL injection, and also continuous delivery tools for Visual Studio and Microsoft, where you can do cred scanning locally. All right, so now we've made a commit, and then it's building in our Azure pipelines. So here we can do static application security testing, software component analysis, and running our security unit tests. So first up, a variety of static application security tools. First, you've got fxcop. Others exist like Scan and modeling checks, but I'm just going to use fxcop here. Sonar Cloud, which is SonarQube as a service, which is a really good product. And then Microsoft Security Code Analysis. So a suite of security tools, which they provide as a package, and the Azsk ARM template checker. So you can check your application code with the first three, and then your platform code with the last one. So first up, fxcop. It checks for all of this stuff: code quality, design flaws, naming, performance, maintainability, portability, reliability, and the one we're interested in, security. In terms of security rules, it can look for insecure SQL, bad class design, insecure processing of HTML or data definition documents. Look for anti-forgery checks are missing, weak cryptography, etc., etc. So the first thing you do is you install the code analysis fxcop analyzers package. I would say at this point that you need a version of Visual Studio that matches the build agent you've got in Azure Devops. Otherwise, you get a load of build errors or warnings, and the fxcop doesn't run. So when you install the package, it installs all of these rule sets here, and you want to grab a copy of this security rules enabled rule set and drag it into the project so it arrives here. And then there's a setting in here. So you just say, run this security rules enabled rule set as part of the build. So if we click on the rules, we can see that of all rules are now as warning. You can also set these errors. So if we, for instance, decide that we cannot possibly have any SQL queries that might have vulnerabilities in them, you can just put that as an error so it won't build, and that will fail in Azure Pipelines as well. And it's looking for LDAP injection, cross-site scripting vulnerabilities. You know, there's quite a lot here. It's quite a good package. So they're all security rules. Right, let's say I'm not using the SHA, decide I'm going to do something very naughty and then do this instead. And I use the SHA-1 manage, which is a very weak hashing algorithm. And then I'll get some squiggles that says it's using a weak encryption algorithm. And I can change that warning from to an error in the rule set, and that will fail the build if I consider that something very bad. Okay, so next up, Cloud, which is SonarQube service. Again, this is gives you a lot of information about your code, not just security issues, but it also shows you how to what's wrong and how to put it right. So you can show bugs, security vulnerabilities, invalid CSS, deprecated HTML, performance issues, code duplication, statistics. It's free for open source projects, so the version I'm using is free. And analyzes where bugs are clustered and can fail the build. It's very simple to set up. So it's just a couple of sections in your Azure Pipelines. So there's 3 steps. Sonar Cloud prepare. So that sets up your account and using a key and password effectively. And then it analyzes your code, and then it publishes the code back to Sonar Cloud. So this is what Sonar Cloud looks like. It said I've got 38 bugs, 87 security hotspots, 568 code smells. It's not that smelly. And 1 security vulnerability. So let's have a look at that one. Refactor this code to not perform redirects based on tainted user control data. Why is this an issue? Okay, let's actually. So here it's taken the code I've got and it's saying, well, if a user can inject this return URL to log in async, which then goes to this section here, which is further down in the class, redirect to URL. So here, redirect, for instance, could be an open redirection. So it steps you through each of the problems with the code where the data flows through, and then you've got these resources down here on how to fix it. So it's a pretty powerful tool for security and for a lot of other things too. Okay, so I'm going to talk about the Microsoft Security Code Analysis suite. So of one of those is the Credential Scanner. Here you can see all of the NCSA processes I've got in the build step. So that's a scanner for malware. This is looking for credentials that I've mistakenly checked in. That's looking at compiler settings. That's looking at my secure TypeScript. Here I'm going to publish a report, and then here it's broken the build because it doesn't like something that I've done. So here I'd actually checked in some credentials, and then it shows where and what it should look at. Includes 25 different searches supporting 70+ file types. So it can find a lot of credentials mistakenly checked in. So it's an XML file. It's not pretty. It's saying web.live.config had a secret in file. Yeah, that's gone through. That's been promoted through to a package as well. So obviously I fixed that one. So as I say, the NCSA is a suite of packages you can use to understand better your security profile. It contains TS-lint, so again, this runs as part of Azure Pipelines. You can check for things it's got all sorts of rules that check for readability, maintainability, and errors in functionality. The security rules like no eval is evil. So you should probably fail a build if you're trying to use eval at any point in your code. It could look for banned terms and then some particular security settings, no string-based timeout, which apparently is very bad. Use strict, probably good sense. It's also got Roslyn analyzers, so I think these behave a lot like fxcop. So they're integrated in your like fxcop as a static analysis tool. They don't get deployed through into production into your build assets. They just run at build. The MCSA produces a report and can be used to break the build if required. This is paying package. It's quite expensive, so I think this is more for your sort of enterprise customers. It's between 5,000 and 7,500 per Azure DevOps organization. So I've got an Azure DevOps organization, but it's only got 4 projects on it. You really need to have hundreds of projects before where this starts paying back, because then the cost per project is really low. That's a good project for what I've seen. So finally, in terms of static code checking, we've got Azsk. So this can run security checks against a resource group. So this is deployed assets in Azure, an ARM template. So this is the settings you intend to deploy into Azure. An Azure subscription. This is how you log into Azure. And they can also, it's got security runbooks that provide continuous assurance of your security profile. So this looks for odd changes, for instance, and has a lot of security telemetry. It's constantly updated, so when you run it, there'll be this big pause as it downloads the latest rules, and there's a link to it. Right, so we're going to be looking at the first two to check the resource group and ARM template checks. Actually, I'm going to run it because it takes a while. So for an app service, it can pick up things like you've not set HTTPS, HTTP2 is not enabled, RBAC is configured, you didn't bother to set SSL findings. Microsoft making the old mistake of having stuff by default enabled, so you should disable WebSockets, disable FTP. You need to do that manually. For availability purposes, you've got to have backup configured, and then auditing and monitoring. So if any nefarious users change things, then you'll find out about it. Because I was in origin resource sharing, not overly permissive. So that's for the app service. For blob service, it's looking for a different set of things. So it's locked down to a virtual network. It's got full HTTP access. Core is not overly permissive, firewalled, soft delete enabled for availability, that kind of thing. So first off, I'm going to look at how you run this against a resource group, and then I'm going to look at how you run it against the ARM template checker. Actually, that's in reverse. Okay. Yeah, I had this problem before. So here I install the module Azsk. So this is on the most up-to-date version of the Azure command line. So this doesn't work with Azure RM. And then I'm doing the ARM template security status checker. So this here I define where my ARM template is, and where my parameters file is, and then anything I want to skip. And I think when I did this with Pete, this took far longer than I thought it should. Okay, it's going to download all that lot again. Yeah, okay, so I might just skip to. So when you've run the ARM template checker, it looks something like this. So here it's passed. So I've got threat detection enabled on the SQL database. It's got always on enabled for the app service. But Azure consider that I need to have an AD admin defined, so it's failed on those. And then it says we need to do a manual check on this one to say, on the blob storage to enable soft delete and see whether that's appropriate or not. So here, it basically gives you a CSV file like this. And these are my exclusions. So it formats better. in Excel, but basically says those are all the rules, like the use an AD admin that I want to exclude. So these rules I don't think are security problems. You check that in with the exclusion file, and so that doesn't fail your build. And if there's anything you missed, then it will fail the build as it when you check it in. Yeah, okay, so it did run in the end. Fantastic. So then it produces the ARM checker results here with all my past services and a few failed services, which then become my exclusion file. Okay, so that's checking the ARM template to make sure that what I'm deploying is has the best security profile. Here I'm checking what's deployed. So this should feed back security into my requirements process. So again, this might take a long time. So the resource group I've got in Azure is called Security Essentials int. So it's checking the security settings for all of these assets, basically. So here you see the last one, it's just checking the storage, and again, we've got an exclusion defined with that. So for storage, HTTPS protocol must be used. And it's found 14 high findings, 1 failed, and then 2 medium failed. And then, of course, it's got a generate fix script. So this actually generates a PowerShell script, which you can run against your resource group to fix all of the security issues. We're obviously DevOps, so we wouldn't use that. We would check in any changes to our ARM template and our own PowerShell script in source control. So those would then flow through to any new environment. Okay, this is going to take a while, so I'm just going to skip that. So next up, software component analysis. So we use a couple of packages here, the OWASP Dependency Check tool, which is very good, and WhiteSourceBolt, which adds a lot onto that. We're going to use Microsoft Security Code Analysis, checking for anti-malware, and doing a bin skin looking for secure compiler settings. So first up, OWASP Dependency Check. It's free. It's got a very good database. It takes all the vulnerabilities, so National Vulnerability Database, or NIST, identifies all sorts of security problems with anything that you've got in your code, that you depend on in your code, not your code. So things like NuGet packages, NPM packages, which could, contain all sorts of security ills, cross-site request forgeries, cross-site scripting, denial of service vulnerabilities, remote code execution, buffer overflow. It can generate false positives, so it needs manual checking. So I'll go through that in a minute. And then you may need to create an exclusion file if you judge that it's not applicable to your setup or you've mitigated it in some way. Okay, so this is the ARM template checker. The group, and it created the fix script. Oops, let's go back. Right, so the OWASP dependency checker, I've downloaded it here. It's just a bat file. It's if you haven't run it for a while, it will update its database first. I said scan this the root of my source code directory. Here is my suppression file. So these are all of the vulnerabilities that I've judged not to be affecting my code. That's the project name, and then I will dump all the output in that file there. So what you get after it's done all the updates is a file that looks something like this. So it's saying, well, it looks like you're using this library here, and it uses common platform enumeration vulnerability. Now, I thought it'd be sensible and do something like hashing, but actually it doesn't. Because it has to live in a world where a lot of people compile their own assets from source code. So it relies on things like the DLL name, the version number, the publisher, that kind of thing. which is why you can get false positives. Right, so here's one we've got here. So it's saying this NuGet package that exists here, we believe it to be this one, and we've judged that because the vendor, the product, and the version match, and we have this confidence level. That's the common platform enumeration. The published vulnerabilities against this common platform enumeration are like this. The CVE code, common vulnerability, is the user resource create function in services module, blah, blah, blah. For Drupal, uses a password of 1. Password of 1, pretty weak, but this package here may have been in use in Drupal, but we're not running Drupal. So although it is a match, this is probably a false positive. You can then generate a suppression here, which you can copy into an XML file. Again, that's in the source code here. So these are some I've already gone through and said, yeah, they don't apply to me. So this one is on system runtime interrupt services. Okay, so that's the same thing. So again, that's a false positive. Okay. So you might go through this and you say, well, you know, this kind of input can cause a denial of service on my system, but I judge this to be mitigated because Cloudflare has a rule that specifically blocks this kind of denial of service. You might say, can do UI web. So that shows method is vulnerable to cross-site scripting. Actually, that's the 2004 version. Yeah, I do need to update my data grid and do something about that. So once you've gone through, you've mitigated the ones you can, you've ignored the ones you can, you've fixed the problems that you can, you create a big exclusion file. Now, security is a big moving terrain. If anything then changes, because this is constantly updating, you can then break the build and go, well, I need to look at this. So WhiteSourceBolt is a different flavor. With all of these tools, there is definitely no silver bullet. I ran all of these against what was allegedly secure code, which I'd kept up to date. And with every pass of every different tool, I was learning something new about the security profile of this package. You know, so WhiteSourceBolt, so it checks the NuGet packages and MVM vulnerabilities, just like OWASP's Dependency Checker does. But it's looking at different things, slightly different way. And also it checks for license risks and compliance. You can get free or paid versions. So the free version covers about 6 languages. The paid version covers about 60 languages. More information there. Okay, I haven't run it actually. You get a pretty diagram like this, which lists all the security vulnerabilities and the security code and the CVE code. So saying, oh, jQuery 1.9, blah, blah, susceptible to cross-site scripting attack. So maybe I need to do that one. And I can set that to fail or ignore it as well. So finally, in terms of software component analysis, looking at the Microsoft security code analysis packs, so a developer can check into some malware and none of the code, none of the SCA components we've looked at so far will pick that fact up. So this malware checker, you need a build agent that uses Windows Defender. So obviously that's a Windows build agent. So that will just fail the build if there's any issue there. Finally, there's bin skim. So it finds if there's outdated compiler settings used and the most secure compiler settings have been used, and also checked if the binary has been strongly signed. So this is really sort of deep security. I found that that there's issues with this in that if there is a problem, it will just fail your build. You know, if some OData NuGet package you're reliant on and there's no patch for has an issue because it's not strongly signed, there's no way of creating an exclusion for that. So I think it's more sort of a run locally, a self-service developed security check rather than something you check into the CI pipeline.
John? Joel is asking, have you looked at SNCC? I'm assuming it's pronounced SNCC, SNCC.io.
SNCC.io, I've not. What does SNCC.io give you?
Yeah, I've got no idea. Hold on, where's Joel? Do you want to ask directly, Joel, or?
Pete, do I have 9 minutes left?
You've got there or thereabouts, yeah. So carry on while we wait.
Okay. So in terms of your security feedback, you can do unit tests, so you can check your encryption or hashing algorithm work. Check email templates contain the phishing warning, the account creation and password reset process is properly enforced. So Netflix use a check where they hash important code related to auth or finance, and that gets emailed to the security team. So if a developer tries to weaken the either of those, or give themselves funds or whatever, they get emailed as soon as there's any code changes, so they get to review it. This unit test just checks that the correct authentication is applied to controllers. So if someone removes the admin role off a controller or removes the authorized attribute off the controller, this unit test will start failing. This unit test, again, this is all in the source code, will check that all of your controllers, Web API or MVC, have the decorated with the validate anti-forgery token. Okay, so now we've checked in, everything's built, and then it's deployed. So once you've got the deployed instance, you can run a dynamic scan and then run your security acceptance tests. I'm going to skip that. Basically, you've seen Azure Pipelines, so that's the build, deploy, and the test phase. So it's got pre-deploy, so that sets up the Cloudflare DNS settings. Post-deploy, that resets the security on the website and wakes the website up, and then a PowerShell script that configures it so that the testing pipeline can have access to the database, so set up known good state on the database, but that's all in the source code. So finally, on to dynamic scans. OSAP, I've heard various security researchers refer to this as toy. It's not a pen test, it's not a toy, it's somewhere in between. Again, it's providing useful information on your security profile. You can check for directory traversal issues. It can do port scanning, attack WebSockets, cross-site request forgery, look for information disclosure, check for SQL injection, et cetera, et cetera, et cetera. So I should have started this earlier. Yes, 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 we can see you updating. Okay, so basically we can import a context. So a context is a set of settings that define how you interact with a website. Okay, so it tells you, tells you what to include. So we're going to include any URLs that have security essentials in them, or we're going to exclude, well, there's some links in the website that refer to all those. We don't want to start pen testing those. It's built on SQL Server and JavaScript and C, and it's Windows. So don't bother trying to do SQL injection on IBM DB2. So this vastly simplifies the checks that it's then going to perform against your application. You can teach it how to log on. So you're saying, well, this is your account logon URL, and this is what you post to it. You can set up some users, which you can then log on to the website. So now I do it a default scan. Okay. And say, where's our offset? Whoops, I've started it in the wrong section. Right, okay. So it'll do something called spidering, which is basically walking all the URLs in your website and then doing a tack. So here you can see it's trundling through all of its rules, looking for vulnerabilities. So what you get out of the end of that, I'm not going to finish that. So yeah. Here, so you get this app scanning report. It's saying, well, your proxy server is giving some information disclosure. You got something wrong with your content security policy. Yeah, I do use unsafe inline. It's that blasted data grid again. Maybe I need to do something about that. Unsafe inline for the script tag as well. So lots and lots of things you might want to look at from a security perspective. Okay, so finally, you've got deployed code, you've pen tested it, you can do some security acceptance tests. So for instance, I've got an anti-throttling attribute on my login page that stops people doing pounding my login page, and it limits substantially how many failed logins you can get per minute. So I can validate that that's working using an acceptance test. I can check the correct HTTP headers are being returned. And it will fail the build if someone's changed them or they're wrong. The account process is enforced, so that's in the OWASP top 10 list of vulnerabilities. And if a user is registering with a pwned password, it will show a warning. Okay, so very quickly, that's what an acceptance test looks like. So this is spec flow and it's running Selenium to interact with the website. So it's navigating to the website, it's checking that it's taken to the home page, it's clicking login, it's putting in attempt 1, blah. It clicks login, ignores the error when it says it's not logged in, attempt 2, attempt 4, and then it asserts that you have requested this resource too many times in the last 60 seconds. So it's checking that the brute force attack will fail in a practical way. So finally, promoting to production. I have to speed up a bit. It does obviously a check from a availability perspective. So it's checking the website is up by pinging it from the US and UK. And then you've got the Azure Security Center. So this is different to the Azsk. So again, it's giving you different feedback about your security profile in Azure. Okay, so if you're interested in compliance and you're going for PCI DCSS, it can tell you that you're passing 38 out of 45 pass controls. Obviously, that's not going to do the entirety of PCI DSS. It's going to do the bits that are related to Azure. This is the bit that I tend to go for, the recommendations. So this is going through all the resorts I've got deployed, and it's saying that I need to enable multi-factor authentication. So that's more on the subscription than on the resource groups. But control of the subscription is also very important because you can bypass all of these checks and audits of the build pipeline. So that one's actually more than one own from availability perspective in case you change anything. So again, that's providing useful feedback for your security profile. So the Security Center helps with setting transparent data encryption, auditing, diagnostic logs are enabled, the correct cause settings, et cetera, et cetera. Also, if you run just in VMs, you've got an Azure agent that can be installed on those VMs. So those VMs can be on-prem or in the cloud, and they're all talking and pushing security information into the same center. So you have vulnerability scans on all of the databases. So that's in the security blade in Azure. And then you get emailed this once a week about all of these databases, and you've got free failing checks and passing checks. So it can provide information on whether you've classified sensitive data. So that's from the perspective of if you've classified it as sensitive and someone accesses it, then you can then audit that access. Correct setting of database owners, this firewall set correctly, etc., etc. So all useful database stuff that improves your security. So things we didn't cover: you need to set up two-factor authentication across the board. It's buried, but it is possible. And also make sure you do that on 2 devices, because one of my clients sold their phone, and the authentication was set up to that phone, and that just caused an absolute nightmare of weeks of talking to Microsoft to unpick that one. Secure, you can edit to your CI/CD pipeline. Your CI/CD pipeline is the center of security where it's enforced. So it's important that they can't bypass that process. Code reviews are a very important way of picking up security bugs. I've not covered that here. And pen tests are still important, but they inform the process. So could we have picked up something in threat modeling? Could we have deployed another static code analysis package that picked up something that was then picked up in pen test? So really that's feeding back into your process. What can we do better? How can we change our process to pick up all of these things in future? So the pen tests have become the residual of what's left over, rather than a security gate, because we need to be deploying all the time. Okay, so we've looked at pull left security, which means fewer defects, capturing security defects earlier. We've got automated deployments, so we can flow through security into production as fast as possible. We've looked at lightweight threat modeling as to identify if we're using new resources or existing resources, what threats are applicable to those, and how we can mitigate against them. We're looking at what we can pick up in the IDE, then static code analysis, fxcop, and then Sonar Cloud for your code, and Azsk for your Azure template. MCSA to pick up a number of things like credential scanners and bad TypeScript code, OWASP Dependency Check, and WhiteSourceBolt for all of the components you have to rely on, and BinSkin for correct compiler settings. So when you've deployed, you're doing dynamic analysis using OWASP Zap, and then looking for security regressions with your acceptance tests. And then in production, you're getting that security feedback via monitoring, via the Azure Security Center, continuous vulnerability scans and database. As I said before, no one tool is a silver bullet. I've learned more and more about my security profile with each one of these. So it's really important to use a selection of those and get as many different voices, different perspectives on your security profile as possible. Here are some resources. Most of my process is based on this book. This is an excellent book on DevSecops by Jim Bird. There's a couple of Pluralsight courses here, which cover some of the tools that we've looked at today. This is the best practices book by Microsoft on securing Azure resources. That is very easy to read, and I'd recommend you looking at that. And the Unicorn project by Gene Kim's just come out, and that will help you understand DevOps better, continuous deployment better, and also some security perspectives as well. Okay, we probably don't have time for questions, but if I'm on Twitter, I'm going to put these slides on SlideShare. There's code on GitHub. If you've got any feedback, good or bad, I'd be really pleased to hear it. Any questions?
Yeah, I think we can. I mean, David was quite malleable earlier, so it's going to be up to him. But yeah, if David says it's fine, then it's fine. I've unmuted everybody I can unmute. This new interface in Zoom is terrible, but I can see that there's people that have muted themselves, and I'm not going to ask you to unmute yourself.
Apologies for a lot of information in a very short time. It was originally a 2-hour talk.
Yeah, again,
a summer blockbuster.
Yes, exactly. Yeah. I feel the need to apologise slightly to John Stavely, specifically because we'd arranged for this to be next week, and then through a blunder of my own, I ended up doing it this week instead. But you know, I'm going to blame various different planning tools that I've got that all had this for last week, for this week rather than next week. Martin Evans is asking, can the OWASP SAP scanning as an automated post-deployment task? And also will DM, but of course no need to now.
Yeah, sorry, I didn't make that clear. Yeah, so that's in the Azure Pipelines template, which is there. So is that the OWASP dependency checker or the OWASP ZAP?
That was the ZAP.
ZAP, yeah. Yeah, so that's where I had to start getting really fast. So basically, this is working on a deployed instance. This actually has a Ubuntu built agent. So because OWASP SAT is Java, so you add it in from the marketplace, and then he says this is the context with all of those settings on how you log in, the URLs to include and exclude. That's the website to go to, that kind of thing. Then there's this horrible bit of boilerplate you stick in from the marketplace. You don't need to write that. So that converts the results from one format to another. Mm-hmm. And then you publish the report as XML. So one thing I'd also say about OWASP is the add-ins that you get are different. I mean, obviously, OWASP is always up to date, the version that Microsoft have provided in Azure Pipelines. But if you run it locally, you can configure different add-ins, beta add-ins, look for specific things, and run it for longer, critically.
Sure. Is the just had a look at your GitHub repo. Is the ARM template that's supplied in that? Did you say at the start that that's something that you'd put together yourself, or had that been issued as like a guideline standard?
Yeah, so that's something I've written, but it's based on numerous previous projects and Azure Security Center feeding back things that I could improve and going through a pen test and that kind of thing. So I think it's a pretty decent security baseline to work from.
Sure, awesome. Thanks for
that. Earlier on, somebody had mentioned SNCC. I'm assuming it's SNCC, but it's SNYK anyway, and that seems to be developer first security and scanning. So I think.
All right. Yeah, I've not used that, I'm afraid. I'd have to Google that.
Yeah, well, website.
We're trialing that at our place.
Oh, is that you, Connell?
It's pretty good. Yeah. Well, no, I didn't ask the question, but we're trialing that at our place, and yeah, we're only a few weeks in, but it seems to be all right. We're calling it SNCC, but it stands for So Now You Know, and apparently their CEO calls it Sneak.
I did wonder what you meant by that, but now I'm being a bit slow. Yeah. Right. Oh, okay. Well, that makes a lot of sense. That's cool.
I'll have a look.
Sneak makes sense, I suppose, doesn't it? Given the...
So is it sort of an IDE check? Is it static analysis? How does it work?
Connell's muted himself. You'll have to do it with hand gestures. Oh, hold on a minute.
I will now illustrate through the theme of mine.
Yeah. No, you should be able to unmute yourself.
That's really weird. Yeah, I muted myself and then instantly pressed unmute, and it said you can't unmute yourself because the host had muted you.
Yeah, it wasn't me. It wasn't me. I think Zoom's having a right mare at the moment. They've given up on security and started adding features no one wants.
I'll try and find a hardware mute from somewhere.
Yeah, that'll work.
We've got it in the build pipeline, but I'm not sure. I didn't set it up myself, so I don't know if you can put it anywhere else. The experience we've got it so far is it's telling us, similar to the OWASP package stuff, it's telling us if any packages vulnerabilities have been found, but as part of the CI pipeline. The most annoying thing for me is when you don't update any of the packages and you just raise a new PR and your build fails because there's now been a vulnerability. It's not detected that we haven't added the vulnerability, and now I can't merge my code.
It's good that someone's informed of these things, though. Yeah, the best tools are all sort of self-service, so you can run them in the CI pipeline and also locally, so the developer has an opportunity to solve the problem before it gets into build, and then avoid that situation that you come across.
In my experience, the security that people pay attention to is the security in people's IDs.
So we're losing you.
Let me try in my theatre voice. Is that better?
Yeah, that's better.
Amazing. In my experience, the security that people pay attention to is the security that's in their IDEs, because it's where people see the workflow of their work. It's where people get their feedback.
Yes. Yeah.
Yeah, agreed.
I agree with that. Yeah, we use Sonar Cloud and Sonar Lint, and you're much more likely to fix something if it shows up in your IDE. You almost confuse it with a build warning or a build error.
Yeah.
I've definitely fired Sonar Cube into the sun once before for failing builds that Sonar Lint wasn't picking up on.
I would point out that there's a lot you cannot pick up through static code analysis. So yes, developers are predisposed to pay attention to what's in their IDE, but you're missing half the story, if not more of the story.
None of the plot twists.
All right.
Do you think there's a good argument there for having a set of post or pre-check-in tests that run on the developer machine that don't necessarily live in the IDE, but rather than just going like git, add, commit, and push, you actually roll it into a process that actually runs the test first and then feeds back to you?
Yeah, what? So kind of like, did the developer run the OWASP dependency checker, that kind of thing?
Yeah.
Yeah. How you'd enforce that? That'll be the trick.
Because it feeds back. You know, it's ultimately something that's going to break a build, right? If your build's set up to fall over because these tests haven't been, because it's failed those tests on the server, then ideally you want to try and get those passing on the dev machine first.
So there's two things I've always thought about this in the past, and one of them is that whenever anyone puts a pre-commit hook in any of my Git repositories, I can measure the time it takes me to disable it in like minutes. And I'm sure it's not just me being a precocious teenager about it. Like, I will disable that stuff if you stop me pushing to GitHub, like I will. What I love, I don't know if you've come across this notion of toxicity tests. It's always been something I've put in on projects before when there's either I love the sound effects in the background. I have no idea what they are, but they're excellent. I feel like I'm speaking from a McDonald's. Where you put in a special CI build that runs on a separate cadence, maybe every 10 minutes, every half hour, every hour. And the entire reason that it exists is to tell you when your code becomes more toxic. And toxic is deliberately vague. Toxic means less secure. It means more copy pasta. It means coverage has decreased. It means generally shittier in any different way. And by kind of unbundling this notion of code toxicity, that you can use that as a metric that you can monitor to track the quality of a code base. There's a really great web app called Code Scene. There's a guy called Adam Thornhill who wrote the book Your Code as a Crime Scene, which he's a former like forensic someone that did medical forensics who used it as a good allegory for doing forensics on code bases. And he's built this product up that's really good. It does things like it looks for code hotspots and centralized points of change and all of these other subtly traveling metrics that are just as valuable to your code base. And I like the idea that all of these things coherently, security and change frequency and hotspots and quality, all wrap up into this nice idea of toxicity. I think there's some, I'm sure Martin Fowler wrote it 20 years ago. But like, I love it. It's amazing.
Well, there's an interesting point in that code not touched for a month might have had some new vulnerabilities identified against it. So should you run a build every month, even if nothing's been checked in? Because the SonarCube rules change, the OWASP dependency checker rules change, OWASP rules change, and then who checks it? Who then fixes
Bit rot is real, right? Bit rot is the thing that kills software.
Well, some people leave their pipelines, the CI/CD stuff, just running, even if it's not changing. It runs. I know Sam Smith, Microsoft guy, he has his checking in about 8 times a day, even if nothing has actually changed. And I guess that would cover that.
That's a bit keen.
It is, but he works for Microsoft, so he can afford to be.
Yeah.
Then we've got something that's like the 10 builds that have the oldest since they've last been built get built overnight or something like that. So you've always got a rolling, so everything's at least
quite
a
cool.
little bit up to date.
I mean, I've worked in organizations where they built centralized components one time in like 2013, then did like a package management clear out for disk space reasons. And then the oldest thing that their whole empire was built on no longer compiled, and they had like a binary they had to decompile. I mean, this stuff is real. Like, your build should always be building. Always be building.
Somebody drank a lot of beer that night.
I mean, also disk space is cheap.
Yeah.
Which was my argument when I said you watted the package management server. You what? Like, I'll go to PC World and buy a 2 terabyte hard drive and stuff it in the back of your AWS server if you like. Psychopaths everywhere. It's fine.
way cheaper than developer time. That's for sure. Oh man. All right, we'll take a break for 5 minutes. If you need to go and refill your glass, whether that refilling point is directly behind you on the bookshelf. David, I'm looking at you.
It's okay. I already went halfway. It's fine.
Good on you. And then we'll come back. What time is it now? It's 20 past. We'll come back at 20 past.
I also got pizza to make you all feel more like you're a real meter.
You did it.
And I've eaten half of it as well. It's the bit that's not on YouTube because I didn't think YouTube needed me stuffing my face for 5 minutes, but I did order the pizza.
Oh, that's legendary. I like that. All right, I'm just going to go and get myself a drink. I'm going to practice what I preach. So I'll be back in a sec.
I mean, I feel if I go off for a break, it sends the wrong message.
I'm scared to mute myself now.
In case you're never allowed to talk ever again.
That's it. I need that attention.
Yeah, you forfeited your right to communication with other humans. Not only do you have to isolate, you can't speak.
But then on the other hand, this room's right next to the toilet, and you don't really want to be broadcasting that on YouTube either.
Right. So I always have this. YouTube are going to understand all my personal details now. My toilet is also behind my office, and this is a wireless headset. So I have this thing where if I'm playing video games or streaming, and I go for as the kids these days call them, bio break. I don't take my headset off. I just mute it with the button back here. So I can go to the bathroom and listen to everything everyone's saying, and you can hear everyone dying in your games or asking questions. You're just like, I could answer this, but I really don't think it's appropriate. Really, truly not appropriate.
No, the sound effects in your background would be inappropriate.
I was going to say, suffice to say, if I need a quick break in the middle of my talk, I'll just go. Don't worry about it. It's fine.
That's all right. You have something under your desk for that problem, do you? My toilet
that would be a trauma.
The old trucker's friend.
Yeah.
This is like the lowest fi version of MTV Cribs ever. Where are your toilets? Love it. Love it. Do I even have any notes? Yes, I do. Amazing. I've got notes.
Oh, notes wonderful. And a slide deck. Yeah.
This slide deck is the most multi-colourful slide deck I've worked on in quite a while.
Like my beer, then.
Amazing. It's literally it's colour keyed to your beer. It's got authentic cat pictures.
Oh.
Self-sourced. I sourced cat pictures. Copyright-free best friends.
You don't even own a cat. I just imagine you running down the street. Come back, cat.
However, I have familiars, and that's good enough. You think I'm joking, but
I'm just trying to figure out, is your shelf actually bending with the booze?
Yes, it
on
is.
the back of it? It is.
Yeah, it is.
Excellent.
That's a thing. IKEA don't apparently rate their bookcases for 3 depth of alcohol. Yeah. There are some books on the Muskeg area or something.
Probably, yeah. It's just that you'll have to like lighten it as the year goes on.
So I don't.
Then...
you can. Okay, so while we're in our break, I'll tell you a story about my bookcases, which sounds like it's not very interesting, because it isn't. But if you want the biggest mistake that was made while setting up these generic IKEA bookcases. If you look very carefully at this one here, notice how the top bit is just wood chip there, because guess who's not smart enough to put the shelf on the right way round and only notice when he's assembled 3 of them. And I considered like getting the veneer just to put over the front of it, but actually it gives it character. It's nice. I've got bendy bookcases that are probably sagging the floor into my downstairs neighbours, and a bit of wood chip. It's great.
all I can think of when we talk about IKEA furniture, I just think of that scene from Deadpool. Where you got the visually impaired lady trying to assemble it, and he's just slagging her off for it. Yeah.
I just like to think, darlings, this is home design. It's fine. Don't worry. It's authentic artiste.
Right, a few people
I just
said
cleared out my
that-
office just so I could play Beat Saber without killing myself.
So I don't play. I do have VR in here, but I've got like the Quest and the Rift, and the Quest is better for not punching through glass things. And these are all glass wardrobes. I'm always terrified if I'm doing VR, I'm just gonna like punch something over here. Like I had to move a monitor that was there because I almost left this through it.
If you're muted and you can't unmute yourself, then tell me in the chat. Obviously, a few people have said that they can't unmute themselves.
I'm going to click unmute on everyone because I believe it does prompt you to unmute yourself.
Yeah,
so
I've done that.
Don't feel like you need to, but I'm going to click unmute on everyone.
I can hear Joel now. Yeah, so apologies if you do get that notification exactly like David said. That's not me telling people in an authoritarian way to unmute themselves.
Speak up.
Yeah. Why are you being so quiet?
No, of course. It's just our own casual incompetence trying to work out why the unmute button doesn't work.
Yeah, exactly. Stupid Zoom making things difficult for us hosts.
Okay, so what time were people coming back? 25 past or 20 past?
20 past 1 minute, I think, or there or thereabouts.
Oh, wow.
So,
well, this is going to be exciting, mostly for me.
Yep, I'll do the same again. I'll mute everybody, and this time I'll remember to unmute David. Go on,
no,
David.
we can leave everyone unmuted. It's fine. Like I'm happy for people to yell things at me while I talk.
Are you sure? Okay, I'm happy with
totally sure. We're gonna ride this through because this is a talk. And I guess I'll start doing my introduction now for the sake of it.
Yeah. I think everybody's back anyway. If not, they can flick across to YouTube and rewind.
Right, it's always weird when. Right, so you get to see all my random stuff on my screen first, which is exciting. You can see my Twitter and the back of my email, and then I click this, and now I can't see anyone. So it's like I'm in the room on my own. Which I hate.
You can. You should be able to turn on the gallery view still, I think.
Yeah, so I'm going to try and now move you all so I can see your beautiful faces.
I am also going to allow all of the participants to unmute themselves. Being as we know there are no Zoom bombers here. Oh, if you want a Zoom bomber, then now's your time. So...
Yeah, like I'm in for it. I am here for it. Like I'm willing to roll with the heckles.
You will notice at the bottom of David's screen that he has subtitles. The only presenter I've seen actually use them, and for 99% of the time it's fine, and for the other 1% of the time it's just very funny. So
yeah. So the interesting story. I got like 3 interesting stories from my opening slide. Amazing. I'm going to try and not take all your time. I have no idea how long this talk is. So if I'm rambling, yell "shut up," and I'll shut up.
It's all right. I'm sure my wife will wind you up about it.
So a couple of things here. One, this is my default deck template that I use for all my talks. It's the only time I've ever forgotten to change the covering image. Yet somehow the image is entirely relevant, which is wonderful. And I just kind of left it here because of exactly that. So, okay, so this talk is brand new. It's kind of come out of an essay I wrote back in last November, and I was having a conversation with someone very, very dear to me, and my partner was saying we were talking about tech interviews, and she'd received this brief for a tech interview, and it was basically like, right, okay, so this is a front-end web dev job. And what we're going to do is we're going to list a bunch of like high-level comp sci architecture things that we're going to interview you on, right? And we expect you to really know all this stuff. And I took one look at it and I thought, what a load of fucking horseshit is this? Who the hell writes this? This is not only garbage, but it's kind of offensive. Like, it sucks that people think this is the stuff that people need to be interviewed on. And I was angry. And like all the good things in the world, you do things out of tremendous love and tremendous anger. And this was a little bit of both. So I wrote this essay, and I've now distilled it into a talk, and we're going to see how it goes. Okay, so I'm going to introduce myself first. I'm David. I'm an independent software consultant based in London in the UK, though that just means now in this chair in this room, which is wonderful. I work for myself, mostly taking roles mentoring developers and doing strategic work in UK .coms. I've done a variety of jobs with really pretentious titles like Head of Engineering, VP of this, Chief Technical Architect, Head Principal. It all sounds a lot fancier than it really is. I just like making things, and I love the people that make things, and I desperately try and spend my time helping and doing things with people that make things. That's why we got into this game. I've written a couple of kids' books about programming websites and games in JavaScript, available at Amazon.com, Get Coding 102. There's my only plug. Because what I really do right now is sit in this room unemployed. It's great, quarantine chic. So someone said the dreaded architecture word, and you're not an architect. Now the great thing about this slide deck is I'm both going to explain really obvious things and really, really not obvious things, because people talk about both the obvious and the unobvious in software architecture as if they're the same thing and that everybody knows them and nobody ever fucking uses the words. So if you're scared when someone challenges your understanding of computational complexity, when all you try to do is put a widget on a web page, never fear, it's probably not as sophisticated or complex as you actually might think. So architecture has a reputation for being unapproachable, gate-kept, and hard computer science. Now, most of the software architecture you run into for average to web scale apps is astonishingly similar, absolutely astonishingly similar. What we're going to do is we're going to cover some of the basics, some of the jargon, and some of the architectural patterns that you'll probably see everywhere in a brief architectural primers for non-architects and programmers and everybody in between. So I apologize if I tell you stuff you already know here. So what even is a web server? Okay, so the very, very basics. So the web, or the World Wide Web, to use its hilariously antiquated, full honorific, it's just a load of computers connected to the internet, right? So the web is a series of conventions that describe how resources, read web pages, can be retrieved from these connected computers. The long story short is that web servers implement the HTTP protocol, which is nothing more than a series of commands that you can send to a remote computer that let you say, hey, computer, send me that document. That's all the web really is. And it obviously sounds familiar because this audience is mostly programmers, and this is just how browsers and APIs work. Nothing controversial here. So when you type my awesome website into your browser, the code running on your computer crafts a HTTP request and sends it to the web server associated with the URL, read the web address that you typed into your address bar. And then the web server, the program running on the other computer that's also connected to the internet and is listening for requests, and it just returns data when it receives them. So there's nothing remarkable about this. The fact that this works is all a small miracle. And it's built on top of DNS, the thing that turns myawesomewebsite.com into an IP address, and a lot of networking, routing, and switching voodoo. Now, the simple truth is that most people building software don't need to understand any of that stuff, even though the interview specs may say you need to, because most people never touch it. So there's a ton of general purpose web servers out there, but realistically, you're probably just going to see a mixture of Apache, Nginx, IIS, and then this new 2015's breed of development stack specific web servers. So Node.js serves itself. ASP.NET Core serves itself with Kestrel. Things like HTTP 4K and Kotlin. We're seeing this broad sea change from general purpose web servers to actually language and platform specific servers. So how does this work at all? And is this architecture? Is this what architecture means when people say architecture? So if you've done any web programming at all, you'll be at least a little familiar with HTTP. It stands for the Hypertext Transfer Protocol, and it's what your browser talks when it talks to web servers. So let's take a look at a simple raw HTTP message. So there's one right there for what at least was my website when I took that screenshot last week. The basics of HTTP are really easy to grasp. There's a mandatory request line. That's the first bit with the verb, one of get, post, put, and head most frequently. There are other verbs, but again, nobody cares. The URL, the web address, and the protocol version, HTTP. It's always 1.1, even though HTTP 2 exists. Again, this is some of the stuff that's now disappearing up into the network stack, and other people will tend to take care of for you. There's a bunch of optional request header fields, all the other junk. It's just extra information you're handing to the web server about you. It's all about you. And after your headers, there's a blank line and some optional body, and that's HTTP 1.1. Like, it truly, truly is. And there's a goddamn like 30-page spec for this, but that's basically HTTP 1.1. And the server responds in a similar form. The first line being a status code followed by headers and a response body. That's it. The web server, based on the content of a request, can send you anything it likes, and the software that's making the request has to be able to interpret the response. There's a lot of nuance in asking for the right thing and responding appropriately, but the basics are all the same. It's important we understand what we're talking about when we talk about the web before we talk about architecture, because representational state transfer, or REST, is something you'll hear about all the time. So this is an authentically sourced cat picture. I'm just saying that's no Google cat. That's a cat specifically sourced for this deck. So the web is implemented on top of the design pattern REST. You hear a lot of people talk about REST as it was originally defined by Roy Fielding in his PhD dissertation. But most importantly, it's just a description of the way HTTP 1.0 worked at the time. So I don't know if it's really common knowledge anymore, as it's the sort of thing that disappears over time. But while Roy Fielding was writing his dissertation on architectural styles and describing and giving a name to REST, he was also working in the working group specifying HTTP 1.1. So the web is RESTful. Fundamentally, it is RESTful because REST was just a description of the web. So the short version of REST, another authentic cat picture, is uniquely addressable URIs, web addresses, that return a representation of some state held on a machine somewhere, web pages, documents, images, and depending on what the client asks for, the representation of that state can vary. That's what the representation meant in REST. So that's HTTP and REST, and both of those things are an architectural style. So what does the architecture of a web application look like? And this kind of comes up a lot. So here's the horrible truth. You can write good software following plenty of different architectural patterns, but most people stick to a handful of really, really common ones. So you're probably coming from, given this is a .NET group, you've probably all heard of MVC, Model View Controller. It's a simple design pattern that decouples the processing logic of an application and the presentation of it. So MVC was really catapulted into the spotlight by the success of Ruby on Rails, ironically, although the pattern itself is a couple of decades older. And when most people say MVC, what they're really actually saying is a Rails-like app, where your code is organized into a few different directories of controllers, models, and views. I remember, like, back in the day in the .NET space, I remember building on monorail before ASP.NET MVC was a thing. And that was very, very specifically a mono clone of Rails. It was kind of in the name. And actually, as an aside, we can never forget how much of a debt of gratitude we owe to Rails for changing the way all web apps were built after that point. Nothing saw as big a change in web dev as Rails. You don't have to love Ruby, you don't even have to like Rails to appreciate that all the stuff that came before was like 3 orders of magnitude more hot garbage than all the stuff that came after. So, as a broad generalization, by default, if you have a URL that looks something like that URL up there, Michael site home index, an MVC framework uses roots, the rules that define where things are looked up, to try and find a controller, in this case home, or a module, depending on your programming language. We can call the things different things, inside some kind of controllers directory. And a function name index would probably exist, and that function would probably return a model, some data that's probably rendered by a view, some kind of HTML template. Now, funnily enough, this is exactly the same today as it was in Rails, as it is in Angular, as it is in ASP.NET MVC. It's a very loud motorbike outside my window. I apologize profusely. And all the different frameworks do it slightly differently, but the core idea stays the same. Features grouped together by controllers with functions for returning pages of data and handling input from the web. That's an MVC app. That's like a third of the whole internet. The single page app with an API. So you might hear cool kids go Jamstack, and it sounds great spread on bread, but these are all the same things as well. So SPAs are incredibly common, popularized by client-side web frameworks like Angular, React, and Vue. The only real difference here is we're taking our MVC app and shifting most of the work it does to the client side. So as an aside, all the people that really love React will probably yell something like, oh, but it's functional reactive programming. Yes, cool, but we basically still picked your web app up and put it in the client and put it into an API. It's the same thing, I'm sorry. So there are a couple of different flavors. Client-side MVC, MVVM. There's now, what's the new hotness? MV something else, not MV present, not model view presenter. I heard there's another one that someone's come up recently. It's basically the same thing again. And there's functional reactive programming. The differences actually are quite subtle at first. So Angular is a client-side MVC framework, follows that same model views controllers pattern, except now it's running inside the web browser. React, an implementation of functional reactive programming, is a little more flexible, but it's even more concerned with state change events and data, often using some kind of event store like Redux or in 2020 React hooks, because apparently the React team hate Redux now. Fine, whatevs. MVVM is equally common in single-page apps, where there's two-way bindings between something that provides data, the model, and the UI. So this is your backbone JS and your knockout JS history. But underneath all these client-heavy JavaScript frameworks is generally an API that basically looks the same as an MVC app, but instead of using pre-rendered pages, returns blobs of JSON. Right? That's what all these things are at the end of the day. And then perhaps the outlier of the whole set, static sites hosted on a CDN or other dumb server. Dumb and Dumber. It was really hard to find a press picture from Dumb and Dumber because people don't upload press kits from 1994. So there's been a resurgence of static websites in the 2010s and the 20-teens. So you see, the secret thing is scaling websites for high traffic is really, really hard. Why did that just pop down? It's just really hard. So we spent years building relatively complicated and poorly performing content management systems like WordPress and all the other things that desperately wanted to be WordPressed that cost a lot of money and a lot of hardware to scale. And as a reaction, moving the rendering of the content to a development time exercise has distinct cost and scalability benefits. Like if there's no code running, it can't crash. It's a very simple kind of thought process. So static site generators became increasingly popular, normally allowing you to use your normal front-end web dev stack, but then generating all the files and using a build tool to bundle and distribute all that dumb stuff to web servers or CDNs. So you'll see tools like Gatsby, Hugo, Jekyll. I have YM in my notes, but I think it's now been renamed to Static. But these tools are common in every language stack. And actually, in 2020, you've got services like Zeet now, which also just renamed itself to something else beginning with V. You've got Microsoft Static Site Hosting, which they just launched at Build. Like there's a reason for all this stuff because it is a lot simpler and it's a lot cheaper and stuff can't break. And then there's the something else category, where I casually sweep under the rug that I said everything's kind of one of three things, but there's also a load of other stuff. So there's a rising trend in transpiled frameworks of certain kinds. So you're seeing this with Blazor in C# to WebAssembly. You're seeing Kotlin's JavaScript compile targets. But with the vast popularity of the dominant JavaScript frameworks of the day, they all have to play nice with JavaScript. And if they don't play nice with JavaScript, they will not survive. This is just the truth. It's not a negotiation point. Things that don't play nicely with JavaScript on the web in 2020 will die. And interestingly, when I've been doing work with Blazor, I found that there still needs to be a bit more work on the Blazor interrupt story. It's great if you're in the Blazor sandbox, but once you try and reference something else in JavaScript, it really don't like it. So why would I choose one over the other? And this is really what everyone thinks when we talk about web architecture. And the answer is really is both simple and a bit of a trick question. It's just a matter of taste, and they're all totally appropriate ways to build web applications. And the kind of awkward thing is when people choose one that they like the most, they tend to think all the other answers are wrong, and that's not true at all. Server-rendered MVC apps are good for low interactivity websites. Even though high fidelity front end is a growing trend, there's a huge category of websites that are just that, websites. They're not web applications. The complexity cost of biting off a large tool chain is just often not worth the investment. It's not worth it. But anything that requires high fidelity UX, almost by default now, is probably React, Angular, or Vue. And it's probably not Angular. And it's probably definitely React. And about 10 dudes use Vue. And about 3 other people. Like, the programming models work well for responsive user interfaces, and if you don't use them, you'll mostly end up reinventing them yourself. That's just the truth. Static sites, great for blogs, marketing microsites, content management systems, anything where content is the most valuable interaction rather than programmability and interactive features. They scale well, they can't crash, and they're cheap to run. So, HTTP APIs, REST, GraphQL, backends for front ends. All right, okay, so you're absolutely going to end up interacting with APIs. And while a lot of the terms that get thrown around to make the stuff sound complicated, actually the core is really, really simple. So most APIs you use or build with are going to be REST-ish. They're going to be REST-ish APIs. You'll be issuing the same kind of HTTP requests that your browsers do, mostly returning JSON responses, though sometimes XML. And it's safe to describe most of these APIs as JSON RPC or XML RPC. And people will decorate these things in a lot of different standards and tools, but they're all one of those two things, really. So back at the turn of the millennium, there was a push for standardization. So we saw SOAP, Simple Object Access Protocol. God, that's a mouthful. SOAP APIs. And while that came with a lot of good stuff, people found the XML cumbersome to read, and they diminished in popularity as a result. So ironically, lots of the stuff that was solved in SOAP, consistent messaging envelope formats, security considerations, schema verification, has subsequently had to be resolved on top of JSON using emerging open-ish standards like Swagger, that's now Open API, and JSON API. And actually, both of their implementations for solving things like security and metadata is like an order of magnitude worse than the stuff that SOAP had. But it's the rise and fall of fashion trends in web dev. That's fine. We're really, really great at reinventing things we already had on the web. And, you know, every time we reinvent things, I think we get a little bit better at it. And maybe some stuff is lost on the way, but then we kind of find our way back. And that's kind of cool. So what makes a REST API a REST API and not JSON RPC? Classic interview question. I'm really glad you didn't ask. So like REST at its core is just about modeling operations that can happen to resources over HTTP. That's it. There's a really great book by Jim Weber called REST in Practice, if you want to do a deep dive into why REST is good and why it's a good architectural style. And it is. Lots of the modern naysaying about REST is relatively uninformed and not too dissimilar to the treatment that SOAP got before it, of just people saying, oh God, these APIs make me behave well when trying to use them. Like, ugh, how tedious. So people really, though, when you talk about REST, people really, really care about what is and isn't REST. And it's a really boring discussion, honestly, like it's not 2010 anymore. And JSON RPC is basically level 0 on this wonderful Richardson maturity model. Which is just a model that describes the various qualities of a RESTful design, from, as it so musically put, Pox swamp to Hatios, hypermedia as the engine of application state. The Richardson maturity model is very, very good, and it's useful for understanding the kinds of APIs you're dealing with, but in practice, I mean, JSON RPC works for most people, right? So REST-ish and sane. So don't worry too much about it, because you can build REST-ish, sane, decent JSON RPC by doing a few things, right? Just a few things. Like use HTTP verbs correctly. Get for fetching stuff, never with side effects. Post for doing operations. Put for creating stuff where the state is controlled by the client. After that, make sure you organize your APIs into some logical resources, some core domain concepts, things like customer, product, catalog, obvious stuff. And then finally, just use correct HTTP response codes for interactions with your API. So you may not be using Hypermedia as the engine of application state, but you'll probably do well enough that nobody will come for your blood, right? Nobody will, because it'll look and smell like a good REST API. You'll also get a lot of the benefits of a fully RESTful API by doing just enough. So resources will be navigable over HTTP. Your documents will be cacheable. Your API will work in most common tools. Using something like Swagger or OpenAPI to generate a schema, whilst kind of sucky, and I'm not a huge fan of OpenAPI, but you're probably doing what most people are doing. And actually, the wonderful thing about all this is if everyone kind of does the same thing, all our tools work. And everyone's really just trying to be productive at the end of the day. But I read on Hacker News that REST sucks and GraphQL's the way to go. Frickin' noobs. Yeah, I mean, we all read that post. So, wonderfully, GraphQL is confusingly a query language, a standard for HTTP APIs, and a schema tool all at once, sharing the same name. Excellent. Really, really great branding. So with the proliferation of client-side heavy web apps, GraphQL has gained popularity by effectively pushing the definition of what data should be returned to the client into the client code itself. Basically, we just hoid all the SQL into the web UI and stuck an API in the middle. That simplifies it a little bit, but there's a little bit like that. It's not the first time these kinds of query from the front-end style approaches have been suggested, and likely will not be the last. What sets GraphQL apart a little from previous approaches, notably Microsoft's OData, which was literally just kind of GraphQL 2010 edition, is the idea that types and queries are implemented with resolver code on the server side, rather than just mapping directly to some kind of, well, always at the time, SQL storage underneath. So there's a little bit more protection, a little bit more authorial intent in a GraphQL code base than there was in the original OData implementations. It's useful for a couple of reasons. It means that GraphQL can be a single API over a bunch of disparate APIs in your domain. It solves the overfetching problem that's quite common in REST APIs by allowing a client to specify a subset of the data that they're trying to return. And it also acts as an anti-corruption layer of sorts, preventing unbounded access to underlying storage. So it isn't quite the same, but it almost is. GraphQL is also designed to be the single point of connection that your web or mobile app talks to, which is really useful for optimizing performance. So simply, it's quicker for one API over the wire to call downstream APIs with lower latency than your mobile app calling at high latency all that internal stuff itself. So GraphQL really is just a smart and effective way to schema your APIs and provide a BFF. So that's a backend for front end and not a best friend forever. But that's very quick to change by the people working that tech stack. So BFFs, okay, cool. Another magic architecture word that kind of got made up about 4 years ago. So imagine this problem, if you will. You're working for Mega Corp, where there are hundreds of teams, or squads. You don't remember, they rename nomenclature every other week from teams to squads to mission teams to Spotify teams. But either way, each group of these people is responsible for a set of microservices. And you're a web programmer desperately trying to get some work done. It's a bus. And a new feature has just launched. So you read the docs, and the docs describe how you have to orchestrate calls between several APIs, all requiring different OAuth tokens and claims, and eventually you'll have a shiny new feature. So you write the API calls, and then you realize that the time it takes to keep sending data to and from the client, let alone the security risks of having to check that all the data is safe for transit, actually slows down to a halt. And this is why you need a best friend forever. Sorry, back end for front end. So this guy here, poor guy, is like the only person when you go to PowerPoint's royalty-free slides, when you type in like best friend, is this guy. I think this guy is everybody's best friend. So a best friend forever, back end for front end, translates an internal domain, megacorp business, into the internal language of the application that it serves. It takes care of things like authentication, rate limiting, stuff that you don't want to do more than once. It reduces needless round trips to the server, and it translates data to be more suitable for its target application. Think of it as an API, but just for your app that you control. And tools like GraphQL and OData are excellent BFFs, because especially with things like GraphQL gelling especially well with modern JavaScript-driven front ends, with excellent tools like Apollo and Apollo Server that optimize some of these calls by batching requests. They're also pretty front-end dev-friendly, so queries and schemas strongly resembling JSON, and it kind of keeps your stack JavaScript all the way down, which for people that only know JavaScript is obviously a really good thing. Cool. And without being beholden to some distant backend team. So now we understand web servers and web apps and APIs. Surely there's more to modern web programming than this. Surely. Okay, so we're probably going to run into some other things. Load balancing. The number of people that have never had to configure a load balancer is enormous, but we all use them, and that's totally cool. So if you're lucky enough to have traffic to your site, and trust me, that's being lucky, but unlucky enough to not be using a platform as a service provider that takes care of this for you, you're going to run into a load balancer at some point. Okay, so don't panic. Load balancers talk an archaic language and are often operated by grumpy sysops, or are just running copies of Nginx, right? So all a load balancer does is accept HTTP requests to your application or from it, and picks a server that isn't very busy and forwards the request. So you can make load balancers do all sorts of utterly insane things that you absolutely should never use load balancers for. People will still try. You might see load balancers load balancing a particularly hot path in your application onto a dedicated pool of hardware to try and keep it safe or isolate it from failure. You might also see load balancers used to take care of SSL certificates for you. So this used to be very common in .NET land, and it was called SSL termination. And if anyone's ever had the misfortune, entertaining pursuit of having to maintain their own physical hardware, you probably had to set all this stuff up yourself. So you'll run into distributed caching. So if one computer can store some data in memory, then by that same logic, lots of computers can store a lot more data. Nice and easy. Okay, so distributed caching was pioneered by Memcache, a little bit of a history lesson here. And you've probably heard of Memcache D. I can never remember. I've never worked out. I've never asked. I'm an imposter. When you talk about Unix daemons, are you meant to say the D at the end? Because people really unpredictably say the D or they don't say the D. And I've never worked that out. So I'm just going to call it Memcache. And Memcache was originally written to scale the blogging platform LiveJournal, the proto before blogging was blogging website LiveJournal in 2003. And at the time, Memcache helped LiveJournal share cached copies of all the latest journal entries across a relatively small number of servers, vastly reducing the database server load on the same hardware. So a little bit of random computing trivia for you. So LiveJournal was run off like 4 servers in the University Hall of a guy called Brad Fitzpatrick, who was more recently famous. I don't know if you've done any Go. The language Go is one of the core committers to the programming language Go. And for LiveJournal, he built his own, this isn't in my notes, sorry, so I'm going totally off book. And he built a language called Brad's markup language, which was a competitor to PHP. And interestingly, you can see shadows of some of the later syntactic constructs that appeared in Go in this bizarro early toy programming language from 1999. I only say that because in a previous life, I had the username David on LiveJournal. I was like user 200 or something, and was amazed to still get my first name. And I contributed to the default themes to the site. Funny stories. So memory caches are used to store the result of something that's heavy to calculate, takes time, or just needs to be consistent across all the different computers running your server software. In exchange for a little bit of network latency, it makes the total amount of memory available to your application the sum of all the memory available across all of your servers. So distributed caching is also really useful for presenting what they call cache stampedes, or the stampeding herd problem, where a non-distributed cache fails and cache data would be recalculated by all of the clients. So by sharing their memory, the odds of a full cache failure is reduced significantly. And even when it happens, only some of the data is recalculated. It's like a really clever, simple solution. So distributed caches are everywhere, and all the major hosting providers tend to support Memcache or Redis compatible, meaning you can just use Memcache or Memcache client libraries across all of them, managed caches. Understanding how a distributed cache works is remarkably simple. So when an item is added, the key, the thing you use to retrieve that item from a cache, is generated to include the address or the name of the computer that's storing that specific piece of data in the cache. Literally, those cache keys point you to one of the computers. Generating keys on any of the computers that are part of the distributed cache cluster results in the same key being generated. That's it. So that means that when client libraries that interact with the cache are used, they understand which computers they must call to retrieve the data. Breaking up large pools of shared memory like this is smart because it makes looking things up exceptionally fast. No one computer needs to scan huge amounts of memory to retrieve an item. Distributed caches are awesome. People forget how awesome they are. Content delivery networks. So God, I remember in about 2011 when CDNs kind of came in, being slightly terrified of them because it just felt like another place to stuff a load of files that I could forget to update, and it definitely happened more than one occasion. So CDNs are just web servers run by other people. That's all a CDN is. You upload your data to them, and they replicate your data across all of their edges. A silly term that just means to all the servers all over the world that they run. So that when someone requests your content, the DNS response will return a server that's close to them. And the time it takes them to fetch that content will be much quicker. Cool. The mechanics of operating a CDN are vastly more complicated than using one, but they're a great choice if you have a lot of static assets like images or especially big files, videos, large binaries. They're also super useful to reduce the overall load on your servers. Offloading to a CDN is one of the easiest ways. You can get extra performance for incredibly minimal cost. So let's talk about design patterns, okay? So we've dealt with like the internet and web browsers and computers and HTTP. Design patterns, real architecture. So design patterns are just bug fixes in your programming language. That's not actually a quote, that's just something I put in quotes. But they are just bug fixes in your programming language. They're things that you do all the time that really should be dealt with more elegantly in your programming language, runtime, or framework that haven't been, and the community collectively has had to paste them all together and document them. So people talk about design patterns as if they're some holy grail, but all the design patterns are an answer to a problem that people solve so often there's an accepted way to solve it. If our languages, tools, or frameworks were better, they would probably do the job for us. And in fact, newer language features and tools often obsolete design patterns over time. This is especially interesting if you maybe 20 years ago or 10 years ago read the Gang of Four book, which is a good book. 50% of it is thoroughly irrelevant in 2020 because it's been replaced by more modern tools. But let's do a quick run through some really common design patterns. So when the next time someone says one, you don't have to pretend that you know it and then go Google it afterwards, which is what everybody does. Okay, cool. MVC. Split up your data model, UI, code, and business logic so they don't get confused. That's all MVC means. ORM, Object Relational Mapping. Use a mapping library with some configured rules to manage the storage of in-memory objects in relational storage. Don't muddle the objects and where you save them together. Active record. All your objects should be able to save themselves because these are just web forms and who cares if they're tied to the database. Repository. All your data access goes in this class. Decorator. Add or wrap decorators around an object, class, or function to add common behavior. But it's always caching or logging without changing the original implementation. Occasionally it's a few other things, but it's mostly just caching and logging. Dependency injection. If your class or function depends on something, it's the responsibility of the caller, the framework you're using, to give you that dependency. Or in 2020 Twitter, something to talk shit about, except everyone uses but like you're cool if you think DI sucks now because you're really enlightened, right? Did I get my bit right? I'm not sure. Factory. Put all the code. You need to create one of these in one place and one place only. I'd love to actually rewrite the whole Gang of 4 book as single sentences per chapter. That'd be excellent. Actually, maybe I'll do that. Adapter. Use an adapter to bridge the gap between things that wouldn't otherwise work together, translating an internal data structure to an external data structure. Basically, you're converting a Twitter response into your social media data structure. Command. Each discrete action or request is put in a single file. And there's only 2 more. Strategy. Define multiple ways of doing something that can be swapped in or out. Singleton. There's only one of these. This is a non-exhaustive list of some of the pattern jargon that you hear. There's really nothing special about design patterns. They're just the 1990s version of an accepted and popular Stack Overflow answer. Okay, cool. So maybe what if design patterns aren't architecture? Fuck. Microservice architecture. Cool. Well, this is just the 3rd wave of SOA. That's all this is. So let's talk about where this came from. So in the mid-90s, COM+, component services, and SOAP were popular because they reduced the risk of deploying things by splitting them into small other things, and then providing a standard and relatively simple way to talk across process boundaries. Oh God, I'm running late. This led to the popularization of 3-tier and later N-tier architecture for distributed systems. Okay, cool. So N-tier was just shorthand for split up the data and the business logic and the presentation tier. Like people always called it N-tier with this wonderful aspiration that had more than 3 tiers, but it was always 3 tiers. And it worked for some people, but it suffered problems because horizontal slices through a system often required changing every tier. Like no one ever cut the wedding cake top down, did they? Like never happened. So this ripple effect is bad for reliability because if you try and cut a wedding cake top down, it falls over. So then product vendors got involved and SOAP became complicated and unfashionable, which pushed people towards the 2nd wave of SOA, Guerrilla SOA. So this was basically a similar design, just without all the high ceremony, with lower overhead protocols and fully vertical slices and less vendor middleware. So it was kind of a push by the community to claw back where we were. And okay, fine. Oh yeah, fine. My notes are all right. I thought my notes and my slides had dropped out of order, which would have been really awkward. Okay, so this led to the proliferation of smaller, more nimble services around the same time that Netflix were promoting Hystrix, which was their platform for latency and fault-tolerant systems. So this 3rd wave of SOA was then rebranded as microservice architectures by James Lewis and Martin Fowler. It was very popular, but perhaps not very well understood. And I remember sitting at like a ThoughtWorks something in about 2014, where James Lewis gave the big microservice talk, and it was really good. These guys are really smart; they know their stuff. So what microservices were supposed to be was small, independently useful, independently versionable, independently shippable services that execute a specific domain function or operation. What microservices often are brittle, codependent, myopic services that act as data access objects over HTTP, then fall in a domino-like fashion if one of them falls over. Okay, awkward. So good microservice design actually follows some very, very simple rules. Be role and operation based, not data centric, which is the partner of always owning your own data store. Communicate on external interfaces or messages. What changes together and is codependent is actually the same thing, so should stay together. And that all services should be fault tolerant and survive the outages of their dependencies and peers. So microservices that don't exhibit those qualities are likely just secret distributed monoliths. And that's also kind of okay, because loads of people operate distributed monoliths at scale, but you will feel the pain at some point when you do. And it's interesting because I know recently there was a bunch of noise on Twitter because Someone described this as macro services, but really it was just microservices again, because they didn't understand what microservices was meant to mean the first time round. And it was all incredibly entertaining, and the Twitters lost their minds a little bit. Okay, cool. So we've kind of done microservice architectures, which lots of people get confused with. Okay, so hexagonal architectures. Well, this has got to be some science. This is real architecture, right? Hexagonal board games. Hexagonal architectures are also known as the ports and adapters pattern, as defined by Alistair Coburn, are one of the better pieces of real application architecture advice. So put simply, have all your logic, business rules, domain-specific stuff exist in a form that isn't tied to your frameworks, your dependencies, your data storage, your message buses, your repositories, or your UI. All of that stuff is outside stuff, and it's adapted to your internal domain model and then injected in when required. So what does that really look like? All your logic is in files, modules, or classes that are free from framework code, glue, or external data access. That's what it really looks like. That's what hexagonal architecture really looks like in code. Why? Well, it means you can test everything in isolation. So it means you can test without your web framework. It means you can test without some broken API gateway going in the way. It means you can keep your logic clear of all these external concerns, and it's quite a safe way to design applications. There's a second quite popular approach that's very similar to this, that's described as 12-factor apps. And basically it shares the same core tenets, right? The same design goals, and it throws a few prescriptive rules on top. Now, scaling. I love talking about scaling. Scaling is really hard to do yourself, so don't do it yourself. Real, simple answer. Don't try scaling your own stuff. It don't work. Use vendor-provided cloud abstractions like Google App Engine, Azure Web Apps, AWS Lambda, that has auto-scaling support enabled if you can possibly get away with it. Consider putting your APIs on a serverless stack to further up the abstraction you get. And the further you go up, the easier scaling is going to be. Conventional wisdom says that scaling out is the only cost-effective thing. However, plenty of successful companies have managed to scale up with a handful of large machines or VMs, so I can't in good conscience say that scaling up doesn't work either. Scaling out gives you other benefits, often geo-distribution related or cross-availability zone resilience, but don't feel bad if the only lever you have is the one that just has more power written on it and you have to pull that. That's fine too. So building distributed systems is harder than building just one app. Nobody really talks about that very much, but it really truly is. And it's much easier for something to fail when you split everything up into little pieces. But you're less likely to go completely down if you get it right. So there's a trade-off here. My street is very noisy, I apologize. And a crow. Goth for life. There's a couple of things that are always really useful though when you're building distributed services. Circuit breakers everywhere. Circuit breakers are probably if I could pick any single thing for using distributed service for building microservice architectures with, I'd say everyone should put in, is put circuit breakers everywhere. Circuit breakers, it's just the police coming to get me. Sorry. I don't know if you can actually hear the road or I'm just narrating things that's inaudible to everybody else. So circuit breaking is a useful distributed system pattern where you model outgoing connections as if they're an electrical circuit. By measuring the success of calls over any given circuit, if a call starts failing, you blow the fuse, queuing outbound requests rather than sending requests that you know are just going to fail anyway. So after a little while, you start to let a single request flow through the circuit, which is called half open. And if it succeeds, you close the circuit again, and you let all the queued requests flow through. So circuit breakers are just this beautiful, phenomenal way to make sure that you don't fail when you can predict that you fail. So if you know your downstream dependency is down, don't call it. It's a really bad idea. Things are going to crash. So they also protect the service that's struggling downstream from being pummeled into oblivion by you repeatedly trying to call it. You'll be even more thankful for your circuit breakers when you realize that the API that you're calling downstream is also run by you, right? Like in a microservice architecture, you're the person that you're going to sucker punch offline if you don't have circuit breakers. Really, really useful. The complementary design pattern for all your circuit breakers, you need to make sure you wrap all outbound connections in a retry policy and back off. What this really means is you should design your calls to be non-destructive. So if you double submit them, nothing bad happens. So this is the big long word idempotency. It just means if you do the same thing twice, it doesn't do anything bad or responds the same way. And that if you have calls that are configured to retry errors, that perhaps you back off a little, if not exponentially, when repeated failures occur. At the very least, to give the thing you're calling time to recover. So if you have retries and circuit breakers, actually you can kind of have an application architecture that flexes quite trivially. Love them. Bulkheads. Bulkheads are inspired by physical bulkheads in submarines. True story. So the idea is that when part of a submarine's hull is compromised, the bulkhead shuts, preventing the rest of the sub from flooding. It's a pretty cool analogy, and it's all about isolation. So things like reserved resources, capacity, or physical hardware can be protected for specific pieces of your software, so that when an outage in one part of your system happens, it doesn't ripple down and kill another one. So things like isolating data stores from one another physically is a good way to bulkhead off. Traditionally in .NET land, application pools that failed distinctly were another kind of bulkhead. You can do things like set minimum concurrency limits for certain calls in multi-threaded systems. You can make judicious use of timeouts, in that it's better to time out than lock up and fall over, or even reserve hardware capacity for important business functions like checkout or payment. So then we've got event-driven architectures with replay and message logs. So events and message-based architectures are frequently resilient. Okay, and this is because by design, the inbound calls made to them are not synchronous. By using events that are buffered in queues, your system can support outage, scaling up and scaling down, along with rolling upgrades without any kind of special consideration. So its normal mode of operation is to read from a queue, and that doesn't change in exceptional circumstances. When combined with the competing consumers pattern, when multiple processors race to consume and satisfy messages from a queue, it's easy to scale out for good performance with queues and event-driven architectures. Like they're really, and this is why a lot of vendor guidance pushes you down these kind of channels. So do I need Kubernetes for that? Right, sounds complicated, right? Absolutely not. You probably don't have the same kind of scaling problems that Google do, which would be when you need Kubernetes. So with the popularization of Docker and containers, there's a lot of hype gone into things that provide almost platform-like abstractions over infrastructure as a service. These are all very expensive and loads of work, right? So if you can in any way manage it, use the closest thing to a pure managed platform as you possibly can. Azure App Services, Google App Engine, AWS Lambda will be several orders of magnitude more productive for you as a programmer. They'll be easier to operate in production. They'll be more explicable and supported. Kubernetes, often irritatingly abbreviated to K8s, along with its wonderful ecosystem of esoterically named additions like Helm and Flux, require full-time ops teams to operate. And even in managed vendor mode on EKS, AKS, GKS, the learning curve is far steeper than any of the alternatives. Heroku, App Services, App Engine, those are things you'll be able to set up yourself for production in timescales measured from minutes to hours, rather than weeks to months. And cloud neutrality. So you'll see a pressure to push towards cloud neutral solutions using Kubernetes in various places. And this is often vendor supported as a push, but it's all snake oil. Being cloud neutral simply means that you pay the cost of a cloud migration, maintaining abstractions, isolating yourself away from useful vendor-specific features perpetually, rather than the exceptionally unlikely scenario that you're switching cloud vendor. You just pay all the cost for none of the benefits and normally get less of the cool things. The responsible use of technology includes using the things most suited to the problem and scale that you have. Make architectural decisions for the problems you have, not the ones you think you may have. So, architecture isn't so hard. Always do the simplest thing that can possibly work. And architecture, just like everything else, has a cost, like every abstraction. You need to be sure that you're getting the benefit before you dive into some of the more complex architectural patterns. And most often, the best architectures, and I truly believe this, the best architectures are the simplest architectures that are most amenable to change. Because there's an absolute truism that for every 2 orders of magnitude growth in your system design, its architecture should change correspondingly. Architecture isn't really so hard. And that's my lot. I got through. And I'm more or less on time. Look at that.
Very good. And a clap for...
that was awesome.
Excellent stuff. And a clap for John Stavely as well. Thanks. Any questions for David?
Stop sharing my screen.
I have a question for David, if that's okay. Can you hear me?
Of course it is.
Yep. Go ahead.
Yeah, thank you very much. I'll just thank you very much for your talk, by the way.
No problem.
I'm just quoting something I think was on the meetup invitation. I think this is from you, so I hope it is. Architecture has a reputation for being unapproachable, gate-kept, and science, I can't remember, computer science.
Something, yeah.
Yeah. So my question to you then is, who are the gatekeepers? Who do they let in, and who do they not let in, and why?
That is a wonderful question. I love everything about it. Okay, so I think there's kind of three schools of architecture that I see. There are the architects who are architects on paper only, who really, I kind of file them under like the cloud solution architect thing. That's unfair because it shares a job title with a Microsoft role that isn't actually there. They're people that maybe I would call enterprise architects who operate in diagrams and they design systems that they never build. I thoroughly don't believe those people are capable of doing their jobs. I don't dispute that they've not done useful things in their careers, but I'm a great believer of, there's this wonderful story, and I forget which Star Wars film it is, of Harrison Ford storming off set while filming one of the Star Wars films because the script was so bad. And the quote is something like, "George, you can write this bullshit, but you can't say it." And I think that's very much that school of architecture is like, cool, these things do look good on a diagram with a bunch of boxes, but you try making 100 HTTP calls and watch it fail in production. Like, absolutely not. So I think that's the oldest school of architecture, and that came from the enterprise architecture track. And you've kind of got these two other architectural models. So there's the architecture teams in organizations where if they're bad, they mandate policy and they describe behaviors of systems. At least they're still technical, but they tell and not do. And then there's the architecture teams that instead of just saying this is what you do, they will provide you with executable, meaningful output, like the architecture team as an open source author model. And I think those are really, really helpful in organizations, and they travel around teams and are like, oh, cool. These are the problems we see across our organization. Let's scale this down and come up with one cohesive solution to it so we can try and solve this meaningfully. And normally they help raise up and take a solution that comes from somewhere else in an organization and canonize it. And I think those are really, really healthy architecture teams. I think there's a mix in where you run into them. So the motivations for this talk obviously was seeing someone write an interview spec. And I have worked with ivory tower architects before. They always hate me completely because we'll go with that. Well, I'll go with a polite smile. Because you sit with them and you watch them try and nail someone in an interview because they've not adequately described like the difference between a binary sort. I'm just like, these people are building React apps. They don't need to know this stuff. Oh, but I had to look like, it's almost the misery loves company approach to architecture. But I had to sit in my comp sci class and learn how to make a B tree. So all you fucks better learn it if you want to put words on the internet. And I have so little time for that tedium.
Yeah, I'm experiencing that myself because I'm actually looking for an entry-level junior position, and I search the web and they say, oh, you must learn all these design patterns, and you're thinking, oh my God. Oh.
And that's the best bit, right? Because most of the design patterns that they think you have to learn are stuff that were relevant when they were junior programmers, but absolutely don't reflect the state of the art in programming today. And I say the state of the art as if I mean like expert level programming. They just don't reflect the tools, the stacks, or the feedback cycles that developers operate in today. Right. Like if you want to learn to be an architect, write loads of software. Right, write loads of software. Look at the things that work for you. Look at the things that don't. But you know what? I have held titles that have chief and architect in them, and all that really meant was that I had a vocabulary to describe the things in simple terms that I saw a lot of the time. That is the real trade skill. And people think it's a comp sci discipline, but architecture done well is a discipline in communication. It's a discipline in taking people on a journey. And actually, in a lot of the organizations that I've worked with, certainly in a couple of, like, I put the principal engineering track into, I'm somehow going to have to answer my door while still talking to you guys as the man. So we're going to do this a little bit.
More pizza.
It's been got for me. It's fine. Fine. That could have been interesting. I can see the street from here. Yeah. I find that the dovetail between the principal engineering track and the track of architecture is really, really interesting, where you have like an internally facing consulting model, where you have, I did this specifically, we did this very well at the train line, where I was head principal engineer or something. I made up the job title. And what that meant is I went around the teams finding experts in their teams who were domain experts and were really good communicators. We then elevated those people. So there was a meta team around the top, and they interacted with architecture, who were thankfully talented. And architecture acted as design guardians, and the principal engineers acted as implementation guardians. And between the two, actually, I found that a really, really natural blend. And it was all about communication. And actually, the people that I remember turning down for the roles were the people that approached it thinking, oh, well, I am technically excellent. It's like, cool, but if you can't explain to me in simple language, then you're not going to help anybody else. Therefore, you're basically useless. You're just a sole contributor. That's the job you have. Stay in it. You're enjoying it.
Yeah, I completely agree with that. I was doing, and it's a bit of a sidetrack, but went on one of the Agile meetings, and I had absolutely no idea what they were talking about. And it seemed like this, like gatekeepers, like you say, it's like you're not welcome into this. You know, you've got to, it's just. And
I find it so hateful.
When you actually look into it, if you Google some of the terminology that they use, you're thinking, is that it? Yep. And it drives me absolutely insane.
There is nothing, I forget, there's a very famous author that wrote this, and I forget who it is. It's probably Ernest Hemingway again, or something like that, my favorite drunk. And it's worse the effect of, like, why say 100 words when 3 would do?
Exactly. Yeah.
Fuck jargon, time and time again. Fuck all the made-up loan words we have. Like, and I guess the thing that I have found immensely powerful in my career is having the nerve to say, I don't know what you mean. Like, not knowing what you mean, like ignorance, not knowing something isn't a crime. Ignorance is not the same as stupidity. And I'm very, very happy to sit in a room with people throwing acronyms around and just go, I literally have no idea what any of those things mean. Can someone, like, just define a few of these terms so we can have a conversation, please? And actually, as an architecture, and everything is about communication. Every single thing in the world is about communication. Programming is about communication. Software design is about communication. Code is just communication between a programmer and another programmer through the written medium of a constrained language. Unless you understand communication, you're going to be a garbage programmer. Like, I say that fully, honestly. That's the one true thing I believe. You don't need to be a mathematician. You don't need to be a statistician or someone that's done physics. If you can't talk, you're never going to write good software. It's not possible. And architecture is just the elevated version of that.
Excellent, thanks.
David, just one thing. So I've managed a lot of developers in the past, and I saw that the guys that can actually go into architecture decently are the guys that can actually see the patterns, the guys that avoid to do the copy pasting all the time and do it again and again and again. And nowadays we have more and more people like that. With these agile teams, you have 100 times the same thing, copy and paste it from the same Stack Overflow post.
I feel like that's a side effect of pressure, though, isn't it? Like, giving people the time to be thoughtful is hard. And it's very, I guess I'm on a bit of a trip at the moment where, like, fuck commercial software development. Like, I love software. I love it. Like, it's my hobby. I adore it. And I've been working in this industry, and they'll pry my keyboard up my cold dead hands, probably. But Agile wasn't meant to force people into those traps. It was meant to give people space, and it's kind of been turned into this rote, hand cranking product fucking like production line, assembly line bullshit that isn't good for anybody. And I think most people, like, nobody gets up in the morning thinking, oh God, what am I going to rip off Stack Overflow today? I mean, I do, but nobody does that, right? People generally want to do a good job. And I find if you give people the ability to talk and the ability to experiment and the slack, like Agile was meant to contain like sustainable pace, literally in the Agile manifesto, or in the 12 Agile methods, principles and values, even attached to the back of the Agile manifesto, is the notion that everything has to be done at a sustainable pace so you can continue working indefinitely. That by definition means you need time for thoughtfulness. And if you don't give people who are working the time to consider the work they do and the time to reflect, you're just going to end up with people churning through shit as fast as they possibly can to get paid, right? It's miserable. I don't know, fuck miserable software jobs. Like, honestly, he says, currently not working for anybody. Irony, not a dead scene.
Cool. Any more questions? Cool. I've got 3 JetBrains licenses to give away. I think some people that may win aren't here anymore, but they can still win. It's okay. We're inclusive here. So I'm going to share my screen. Can you see this? So this is We'll Decide. I did have another one that would actually draw hashtags, but the site seems to have stopped working, and the rest of the ones that want you to do that want you to sign up and access Twitter and give them firstborn and
prize wheels as a service. That's a great business.
Yeah, exactly. But this one, you just type stuff in, so you can see the people that have tweeted on the hashtag .NETNots. So if I hit this, we will find out our first winner. That is going to be, and I know he's already gone, Joel Hammond Turner. So I'll write him down. All of these licenses, by the way, will expire in 2 days' time. So when I tweet you a DM, then use it immediately. Otherwise, it will expire because I've been so bad at giving them out, as I explained earlier. Then I've got, well, to be fair, only 2 of them expire in 2 days' time. One of them you've got a couple of weeks, but I'm not going to tell you which one that is. I'm just going to tell you to go and do it. So next we have, is that Macy J? Macy J, well done. And the last one is Greg Bowie. Okay, there we are. So we have our 3 winners. So they get a 12-month subscription to any one product in the JetBrains pack there, Rider or ReSharper.
That's a good pub conversation, isn't it? Like, any JetBrains product, which one do you choose?
Yeah.
Which one's the best value?
Yeah, you'll get about 73 different answers because they got like 73 different products. They've got a lot of
73 different copies of IntelliJ with different logos.
Yeah, pretty much. Yeah.
And ReSharper.
Yeah, of course. I saw one of the Tech Nottingham people complaining at JetBrains earlier about his. I think it was WebStorm's rename not working properly and always given up and all sorts. But I suppose if you're going to rename every single instance of something in your project, you kind of want to trust that that's going to work. So
you want the most expensive find replace tool you can buy.
Yeah, pretty much.
I adore the JetBrains stuff. I don't know if you guys have much experience. I mean, they're all brilliant, right?
Yeah.
I'm hearing really good things about Rider. Loads of people saying that's dead good.
Yeah, I bought Rider.
Yeah, I've been using
Rider
Rider
Linux box. Fantastic. Really good.
Yeah, so there you go. So I do like it.
You get them there. Well, Rider you get free for open source. So I've been using it for 2 years.
There you go. And if you're a student, I think there's a free tier there for students.
Yeah, they're the good guys, JetBrains.
So there's a few things. In fact, before I read those ones out, tomorrow night, I know at the end of John's talk, he mentioned Gene Kim. Devops Knots have got Gene Kim. So if you are at all interested in pursuing a little bit more about DevOps, then I urge you to go and have a listen to that talk.
He's really good.
Yeah, so I'm really looking forward to that myself. The Agile Engineering podcast, of which I am one of the I don't know, authors, I don't know what you say, podcasters. We've just released our host. Our 5th episode has just been released, so there's that. And then Steve Collins has quite rightly pointed out that Scott Hunter on the 29th of May is at .NET Southeast, so that's going to be awesome. And then next month, .NET Oxford have managed to snag Scott Hanselman, so that too will be awesome. So yeah, there's so many good talks out there. I'm in the lucky in certain respects position that .NET Knots is booked until October theoretically. So what I don't like doing is bumping local or I say smaller. Obviously, everyone's smaller than Scott Hanselman. Speakers for people like that. So I've just not done that because I've got people booked in already. But I implore you, if you've got some time, go and listen to those talks. That'd be awesome. So good. Thanks again to John and David for their talks. They were fantastic. So
Thanks,
round of applause for
Thank
them.
you for coming. I appreciate it's a bank holiday.
Yeah, well, and blame me if that was a problem for you, but I'm guessing that bank holidays A aren't a thing because people aren't going away, and B, it's just another excuse to drink beer while watching somebody else drink rum.
It's like ... something in this current climate.
Yeah, exactly. Yeah. So it's all good. And thank you all for coming. Thanks to JetBrains for the free licenses. Thanks to Stickers for the stickers that you all can't have. And thank you to me for hosting. So next month, 29th of June, I think it is, we'll have Ian Johnson. He did tell me actually what his talk was going to be on, which was, hold on, I'll tell you. He said it was going to be complex system design in nature. So
Ian's great as well. I don't know if you've seen the talk before. It's really, really compelling.
Yeah, he does a lot of that. What do you call it when you draw stuff about meetups?
Sketch notes.
Sketch notes. He's cracking, just some awesome ones. That just a thoroughly nice guy as well. So that'll be interesting. And I think I'll probably have another person alongside. If I can get the person I was supposed to have, then all being good. If not, I'll see if Satya Nadella's free.
Get him on the Satya phone.
Yeah, that's easy. It's just here.
I like the idea. I do like the idea of a bat phone for Satya. Come and fix my computer.
Yeah, that's right. Yeah, Windows isn't starting up. Got a blue screen.
I bet he'd take the call as well.
Yeah. Reinstall Windows for you, and be thoroughly nice about it as well. Good. So I don't intend on cutting everybody off. If there's conversations you want to have or more questions you want to ask, then by all means do. And if you've had enough, then cut yourself off.
I'm here all night. Everyone disappears.
Yeah. No, we just want to see how much of that back shelf you get into.
I mean, I will do shots with anyone that'll do shots with me. Oh God, we're still streaming to YouTube. I'm not meant to say things like that.
Oh yeah, actually, I will actually stop YouTube streaming now.
Stop the YouTube streaming.
Yeah.
Well, in that case, I'll get the spirits.
I was gonna say, get the spirits. Like I'm deadly serious. I mean,
guys, I'm gonna have to go, but thanks everyone. And any questions, I'm on Twitter.